classroom, here's some information about the Math 095 Unit 4B Desmos activity. For the check-in, how to know what topics to expect on quiz number 4. Remember that we have a list of goals or objectives at the top of our unit in Math 115, Math 115 in Canvas. So we have a list. We had this task earlier this semester. I was wondering how many cubes it takes to build this little figure over here. And I let you know that there are 9 cubes on the bottom layer. We have 2 layers of 9 cubes, so it's going to take us 18 small cubes to get there. The follow-up question, is it possible to build a rectangular solid like the one above, but if we had 40 cubes, could we do that? And as long as our dimensions give us a product of 40, when we multiply the 3 dimensions together, we're in business. So something like this one, where it might be like 5 centimeters by 4 centimeters by 2 centimeters, that would make good sense for a little rectangular box. And 5 times 4 times 2 would give us 40. That would be 40 cubic centimeters in that case, and we'll get to the units a little bit later. But something that measures 5 by 4 by 2 would work, 10 by 2 by 2, 5 by 8 by 1, all of those things give us a product of 40. So yes, it is possible. For a box, if we want to find the volume, we'll multiply the dimensions together, length by width by height. It doesn't matter what order we go in. 10 times 5 times 6 ends up giving us 300 cubic centimeters. Here's a new box. I ask for 2 features, the volume and the surface area. The volume is my favorite. Multiply your dimensions together. 96 cubic inches is what we would get for the volume. For the surface area, yes, there's a surface area formula. If you would like to use that, then go ahead and do that, and then just make sure that in the end you get 128 square inches for your final answer. I like to analyze my boxes in pieces and parts, and so I've split this up into the front and the back, the left and the right, the top and the bottom in partners, and then I add all of those together. I have a follow-up question for you. How would your answer change if the box had no top? So if we were to eliminate this top portion, what will that do to your answer? And what would your new answer be? It's just something to think about. For this one, here's some more puzzling. I'd like the missing edge length, and some students did this by trial and error. They did 6 times 3 times maybe 2 and figured out what that was and realized it wasn't 90, and so then they needed to start again. Oops. You could also do it algebraically. If you do 6 times 3 times x has to be 90, and then work on that a little bit. 6 times 3 is 18. To get that x all by itself, we'll need to divide both sides by 18, and we find out the x is 5. So guess and check would get you there, or a little bit of algebra. And you can also check at the end. 5 times 6 times 3, oh, that's 30 times 3, which is 90 cubic inches. For cylinders, we started our cylinder volume work today, and so here's some information you would probably like to have on hand. The volume of a cylinder will be pi r squared times the height, and we need the height and the radius somehow to figure these out. Here's a specific cylinder. The radius is 2. The height is 5. You can fill into the pi r squared h formula. You should get 63.83 cubic centimeters, rounded to 2 decimal places. For this one, we're also given the radii and the heights of 2 cylinders. If you type your work in, like I typed mine in like this, and I hit return, it'll do the calculation for me. This will also work if you type in 226.2. So you could type in just the decimal value. For the right-hand cylinder, if I come over here and do this one, that's going to be pi times the radius, in that case is 6, that gets squared, times the height of 4. You could type it on your calculator, or you could just hit return right here. It's actually checking my work for me. I get the beautiful green check marks. That right-hand cylinder has a volume of 452.4. We have moved to volumes, which are 3-dimensional objects. These were measured in, volumes are 3-dimensional features of objects. These were measured in inches, so we should be talking about cubic inches. Volume is a 3D feature, so cubic units. That's going to be our plan for volumes. In this case, it was inches, so cubic inches. Then I give you this. It looks kind of like a fancy cake. I only ask what features could we compute and what their units would be. We didn't actually go through and do the computations. So we could find the surface area. That would be measured in square centimeters. We could find the volume. That would be measured in cubic centimeters. Notice that the centimeters were given over here in the diagram. And then the last page was a check-in page. You can check the list of goals for Unit 4. If you have things that are concerning for you and you didn't get to ask about them in class today, go ahead and send me an email. I'd be glad to get back with you. Or you could check in with the Math Center on specific styles of topics.